two forces act on an object. Force 1 has a magnitude of 10 newtons and acts at an angle of 30 degrees above the positive x-axis. Force 2 has a magnitude of 15 newtons and acts along the positive y-axis. Find the magnitude and direction of the resultant force. The first thing we're going to do is graph the problem. Our force 1 has a magnitude of 10 newtons and acts at an angle of 30 degrees above the positive x-axis. This means that the force is moving somewhere in this direction. We'll pretend that this is 30 degrees. Force 2 has a magnitude of 15 newtons and acts along the positive y-axis. So it is moving somewhere over here. The resultant force will then be somewhere out in this direction. In order to find the magnitude of the resultant force, we will have to break the force up into its x and y components. To do this, we have to find the x and y components of each individual force. Force 1's x component is equal to the magnitude of force 1 times cosine of 30 degrees. And force 1's y component is equal to the magnitude of force 1 times sine of 30 degrees. We know that they are cosine and sine because we are doing this relative to the positive x-axis. Plugging into the equation, we get 10 newtons times cosine of 30 degrees. This gives us 8.66 newtons. For force 1's y, we get 10 newtons times sine of 30 degrees, which gives us 5 newtons. The x component of force 2 is equal to 0. This is because it only moves in the positive y-axis and has no movement in the x-axis. And the y component of force 2 is equal to the magnitude, which is 15 newtons. Now we need to find the resultant x component, which is equal to the sum of the x components of forces 1 and 2. This is equal to 8.66 plus 0, or just 8.66 newtons. The resultant y component is equal to the sum of the two y components of the forces. This is equal to 5 plus 15, which is equal to 20 newtons. And the magnitude of the resultant force is equal to the square root of the sum of the x and y components of the resultant force squared. Plugging in, we get the square root of 8.66 squared plus 20 squared. And this gives us 21.794 newtons. Now to find the direction of the resultant force, we will use the trig function tangent of theta is equal to the opposite over adjacent legs. And theta is equal to the inverse tangent of the opposite and adjacent legs. The opposite leg will be equal to the y component of the resultant force, and the adjacent leg will be equal to the x component of the adjacent force. Now we can plug in to find that theta is equal to the inverse tangent of 20 over 8.66. Plugging into the calculator, we get that theta is equal to 66.57 degrees. And our final answer is that the resultant force has a magnitude of 21.79 newtons and is 66.57 degrees from the positive x-axis. If you found this video helpful, don't forget to leave a like, subscribe, and let me know in the comments what topics you'd like to see next. Thanks for watching.